Okay, this is Mr. Herman back with a different video this time. This time we're going to work on specifically looking at some of these fish tank problems we've been doing in class. So this first question says a fish tank with a base dimension of 50 centimeters by 36 centimeters and a height of 24 centimeters is filled with 15 liters of water. The cone shown to the right is dropped into the tank. How many inches does the water rise? Round, of course, at the end. It wants it in inches. So the first thing I got to do is recognize that this is probably not going to be drawn to scale, but I can still kind of draw a tank out. It doesn't have to be perfect. Just draw a rectangular tank. Draw your mounts here. And you can always pause these and stop if you have to, if I'm going too fast. From here, I'm going to label some of the dimensions of the tank. So 50 centimeters by 36 centimeters. And the height of 24 centimeters. There's many ways you can solve this, and in a lot of the ways, you don't even need the height at all. It doesn't matter. You'll see why in a minute, too. I want to know how much it rises. So really, there's like a starting point. So it says it's got 15 liters of water in it. Again, that's really almost useless information, but it doesn't hurt. In a lot of problems, you will need it, but not in this one. So we start with this 15 liters of water. It's got a height. We'll just call that h sub 1. And then we drop the cone in. And then the cone's in there, and after the cone's put in, let's draw a cone here, floating to the bottom there. It will rise the water a little bit. The water will rise, and that's going to be h sub 2. It doesn't really matter how much water's in the tank, as long as it's not going to overflow, at least that is. All we want to know is how much it rises. The 15 liters is definitely not full. It's partially full. Doesn't really make that much difference. 15,000 centimeters cubed. You can calculate what the volume would be with these, and you'll find it's not enough to overflow, so it's fine. So after that, I think I'd probably start with looking at the cone a little more closely, because I got to find out what the volume of that cone is. Really what happens is this. You're thinking about this in the sense of your cone is got a volume. This has a volume, okay? And then this part it raised by is a prism with a base dimension of 50 by 36. So that prism then is equal in volume to the amount of the cone. So based on that, let's take and figure out the volume of the cone and go from there. So the volume of the cone would be, let's see, you got inches here. We got to convert these so we can use these a little bit better with the centimeters. Now you can change all the centimeters to inches also, but I would probably go to centimeters because I've already got, it just seems to me like this real straightforward way, but it doesn't really matter. You're going to need these later on, so that's why I'm thinking centimeters. But you can do it however you want. Doesn't matter. It'll still work out either way. So let's start by converting each of these by multiplying by 2.54. Oh, sorry, I did that one already. 2.54 gives you 25.4, and the other one would be 10.16. So this one is 10.16. And these are now in centimeters, so we get rid of the old ones. Don't need those anymore. And I noticed that I need, in the formula for this, to find the volume of the cone, that's a third pi r squared times the height. I need pi, which I have. I need the radius, which I have. I need the height, which I don't have. I have a slant height given. I need this height here. So really, if I've got a 25.4 centimeters here, and I got a 10.16 here, I can use Pythagorean theorem to find, like, say, B or A. And we'll use it in the reverse form. We talked about this before. You can just do c squared minus b squared equals a squared. Remember, the a and b are interchangeable, so it doesn't really matter how you organize these two here. So from there, now I'm going to take the amount, so 25.4 squared minus the side. Again, I use b here, but it could be a, same thing, minus 10.16 squared. And that will equal c squared. I'm sorry, a squared, sorry. And then from there, we get a total here of 500, and if you use your calculator, you'll find this out, 541.9. You can leave it in the calculator, something like this. Take the square root of both sides. Remember our shortcut there, caret 0.5, this right here. And that'll give you the square root, which is 23.28. So now I've got a height I can use for up here for my volume. And that's also centimeters. So now let's go ahead and put that in. So the volume will equal, I'm running out of space here a little bit. Let's put it over here. We'll try to write small. Actually, I'm going to erase this. I'm going to erase this stuff here. So you can always go back and, if you want to go back and pause it and see this part, you can see it again. I'm going to now substitute it because I'm running out of space to put it. So there's our 23.28. We're going to put that in for the height. So I get the volume of the cone, 1/3 times 3.14. The radius was 10.16, right? 10.16 squared times the height of 23.28. And I get a volume of 2,515.24 centimeters cubed. Now, remember, we said that the volume of the cone was equal to the volume of this yellow area here, which it raised up. So if those volumes are equal, I can find the height just by setting the volume for the prism up. So base area times height. Let's get rid of this too. Makes it a little bit neater. And now the volume is, as we said, 2515.24. The base area is 50 of the tank. 50 times 36 times the height. Then you want to take both sides and divide both sides by the 50 times 36. And we get a height of 1.397. And that's in centimeters. So if I want to convert that to inches, which I think it asked for, 1/10 of an inch. So we convert that by then dividing by 2.54 centimeters in an inch. And that should give us 0.55 or approximately 0.6 centimeters is how much it goes up.